How does the observer effect cause the measurement problem? Imagine trying to look at a tiny, invisible world where particles can be in many places at once. It sounds like science fiction, but it's real in the world of quantum physics. The observer effect is the idea that simply watching or measuring these particles changes what they are doing. This effect is at the heart of what scientists call the measurement problem. It raises a big question. How does measuring a quantum system turn a cloud of possibilities into a single, definite outcome? In everyday life, we think objects have fixed properties. A ball is round and a chair is solid. But in the quantum world, particles like electrons don't have specific positions or speeds until we measure them. They exist in a superposition, meaning they are in many states at once. Think of it like a coin spinning in the air, showing both heads and tails at the same time. When you catch the coin and look at it, it lands on either heads or tails. The act of observing forces the quantum particle to pick one state instead of being in many. This is what makes the measurement problem so puzzling. The mathematical description of a quantum system, called the wave function, includes all possible states. But when we measure, the wave function suddenly collapses into just one state. The question is, what causes this collapse? The observer effect suggests that measuring disturbs the system. When a detector interacts with a particle, it changes the particle state. This interaction is unavoidable because measuring devices are physical objects that must touch or influence the particle in some way. This disturbance is why the wave function collapses. It's not that the particle was in a fixed state all along, but that the act of measuring creates a new reality. Some scientists think that consciousness itself might influence this process, but most agree it's the physical interaction with measuring tools that causes the change. This interaction turns a superposition of many possibilities into a single, observed outcome. The strange part is that this effect blurs the line between what is real and what is observed. It suggests that at the quantum level, reality depends on measurement. Without observing, particles stay in a state of uncertainty. Once observed, they settle into a specific state, and the superposition disappears. This quirky behavior is one of the weirdest features of quantum physics and makes scientists question how the universe really works. So, in simple terms, the observer effect causes the measurement problem because measuring a quantum system disturbs it. That disturbance forces the system to choose one outcome from many possibilities. This process is what makes quantum physics so strange and fascinating, showing us a universe where observation and reality are deeply connected.